Hello students, welcome back to Programming in C language. The previous session we discussed in detail about what is data, what is information, data versus information, data hierarchy. There we discussed in detail about what is bit, field, what is bit, byte, field, record, file, database. We discussed in detail with some real-time examples. Also, I explained clearly about what is bit, how to represent bit in different manners like 0, 1, 2, 3, 4, so on, 8 bit representations. We had discussed in detail, right? Bit representation calculations. Okay. The decimal number 0 to 9 we can call decimal number system, 0 to 7 octal number system, 0 to 15 hexadecimal number system. There also we discussed how to construct the binary table. Okay, fine. Today we are discussing in this session the main agenda of this session about data measurement chart. Okay, here we are discussing about bit, nibble, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, hexabyte, zettabyte, yottabyte. Okay, in the previous video we discussed about what is bit, how to calculate these bit representations, how to make the combinations of bit representations. Okay, yes, we discussed in detail. In this session we try to discuss actual data measurement chart. Okay, and also I give some introduction about ASCII code, because in C++ we are writing the code based on the ASCII standards. You need to understand here what is ASCII representation code. See, and some suitable examples. So this is the agenda of this session: data measurement chart, ASCII code, and suitable examples. Okay, yeah. Is coming to the data storage units chart. Here I arranged with the from smallest to largest. See, what is the smallest unit of the computer? Bit. Okay, bit represents what? 0 or 1. It is the smallest unit of the computer. Try to look out very carefully here. I written some symbols. Okay, small b, it is represented by what? Bit. Okay, always the bit is represented by what? Small b. Okay, what is the capacity of that bit? It can store either 1 or 0. Okay, general we can call on or off, plus or minus, like that. Okay, but in computer the bit is represented by small b, that is represented by what? 0 or 1 in the binary format. Coming to byte, in the previous video I explained clearly about what is byte, how to calculate these 8-bit register is combination, 8-bit combinations from 8 zeros to 8 1. Also we given some decimal values, right? 256, but we can calculate up to 0 to 255 unsigned characters I explained. Okay, fine. Coming to here, 8 bits represents what? 1 byte of memory. Okay, 8 bits represent what? 1 byte of memory. 8 bits is combination is what? 8 zeros. Like that we can write up to 8 zeros. 4 zeros, 5, 6, 7, 8. See, this is a combination of what? 8 zeros, 8 ones. Okay, 8 bits represents what? It is a combination of what? 8 zeros, 8 ones. That combination represents what? 1 byte of memory. Through the programming, if you want to store any one character into the memory, okay, it occupies minimum how many bytes of memory? 1 byte of memory. Example, I want to store A, then it going to be allocates 1 byte of memory, either small a or capital A. Okay, capital S, small s. Okay, like I want to store any one character into the memory. It occupies how many bytes of memory? 1 byte of memory. 1 byte represents what? 8 bits of memory. 8 bits, nothing but what? Combination of what? 8 zeros and 8 ones. Okay. Coming to the difference between bit and byte, always remember bit is going to be represented by small b. Byte is represented by what? Capital B. Okay. So if you go and check it out in the internets, they may write like kbps, right? KB. They may write small b. Okay. Sometimes they may write what? Capital B. Okay. There is a difference between what? Small b and capital B. Small b represents what? Bit. Capital B represents what? Byte. Okay. See, be aware about that one. Next, kilobyte. Kilobyte is nothing but what? Representation is what? KB. Okay. Capital B. Kilobyte. 1024 bytes represents what? 1 kilobyte. In the previous video, I explained 2 to the power of 10 represents what is the value, ma? 2 to the power of 10 represents what? 1024 bytes. Okay. 2 to the power of 8, 256. 2 to the power of 10 means what? 1024. See, these 1024 bytes represents what? 1 kilobyte. Okay. The memory is going to be calculated in kilobytes. 1024 bytes represents 1 kilobyte. Similarly, 1024 kilobytes represents what? 1 megabyte. 1024 megabytes represents what? 1 gigabyte. 1024 gigabytes represents what? 1 terabyte. 1024 terabytes represents what? 1 petabyte. 1024 petabytes represents what? 1 hexabyte. 1024 hexabyte represents what? 1 zettabyte. 1024 zettabytes represents what? 1 yottabyte. See, this is about what? Data storage unit in computer. Whatever you can take the examples like memory cards, pen drives, hard disk. Okay, you take any kind of storage unit like CD, DVDs, floppies. You can take any kind of storage unit or memory unit that going to be represented in the form of what? This is a unit representation. The smallest unit is called bit. After that, combination of 8 bits represents what? Byte. The symbolical representation of bit is small b. The symbolical representation of byte, capital B. Kilobyte, KB. Megabyte, MB. Gigabyte, GB. Terabyte, TB. Petabyte, PB. Exabyte, EB. Zettabyte, ZB. Yottabyte, YB. See, in the computer, whatever the memory is going to be storing in the form of these data storage unit, we are going to be representing. Okay. See, always remember these 2 points. I clearly explained in the previous video and in this video. Okay. And the remaining things are 1024 bytes represents what? 1 kilobyte of memory. Similarly, all these memory representations. Okay. So in real world at present, most of the users are familiar up to what? Terabytes, because so in the market these terabytes hard disk are available. 1 terabyte, 2 terabyte internal hard disk, external hard disk available in the market. See, 1 terabyte represents what? 1024 gigabytes represents what? 1 terabyte. Okay, like that we can able to store that much of huge memory. See, up to what? Yottabyte I discussed here. Okay, I hope you clear about this data storage unit chart. Up to here, up to yottabyte is more than enough. Okay. Yeah. See, coming to in detailed description about each and everything. Okay. See, roughly I try to explain. In the previous videos also explained clearly about these. Okay. Once again I'm explaining. Yeah. Bit represents what? 0 or 1 representation. Simply sometimes in general words we can call on or off. Okay. Nibble represents what? 4 bits. 4 bits represents what? 1 nibble. It is a combination of what? 4 zeros and 4 ones. So in the previous video I taken with one example, I explained clearly how these bits are going to be formed, combination and converting this binary into what? Decimal value. I explained clearly. Okay, just go and check it out there. byte. 1 byte represents what? 8 bits. 8 bits represents what? 1 byte of memory. In the 1 byte we can able to store one character. Okay, in computer, if you are storing one character or if you are giving one instruction, it's going to be allocated 1 byte of memory. Next, 1024 bytes represents 1 kilobyte. It is nothing but what? We may write 2 or 3 paragraphs of text. We may able to write in the kilobytes. Coming to megabyte, 1024 kilobyte represents 1 megabyte. There we can able to write generally 873 pages of plain text, 1200 characters. Okay, like that. So it is going to be calculated in the form of what? Bytes. This is a value of bytes. Coming to gigabyte, 1024 megabytes represents 1 gigabyte. There we can able to write, see, like so many plain text, books, like web pages, digital pictures, audio files, mp3 files, like that we may able to write in the GBs. Okay, so in the market, you may check it out, like 2 GB pen drives are available, 2 GB memory cards are available, 4 GB, right? 4 GB memory card, 4 GB pen drives, 8 GB memory cards, 8 GB pen drives, like that. Coming to computer, like 50 GB, 150, like 250, 500 GB, like different memory allocations are there. 500 GB hard disk is available in the market. Okay, there we can able to store huge amount of data in gigabytes. Coming to terabyte, 1024 gigabytes represents what? 1 terabyte. See, this is very huge storage. Okay, like we can able to see, there we can store any number of data. Okay, right. See, this is what? Different kinds of storage. Coming to petabyte, 1024 terabytes represents what? 1 petabyte. 1024. See, 1 TB, 2 TB is more enough for storing what? In a personal computers. Okay, the personal computers, 1 TB is more than enough. For, see, currently at present, I am going to be using like 2 terabyte hard disk. Okay, like that. In computer, more than enough for 1 TB and 2 TB for personalized. We can store huge amount of personalized images. Okay, audio files, video files, movies, like documents. We may store huge number of data, that is more than enough for 1 terabyte. But in the market, 1024 terabytes combination represents what? 1 petabyte. Okay, see, large volume of data we can able to store in the petabyte. Okay, so in the advanced memory is also available, data storage units available. So check it out, 1024 petabytes represents what? 1 hexabyte. Okay, next, it is very huge data. 1024 hexabytes represents what? 1 zettabyte. Okay, it is more huge comparing to what? Hexabytes. Okay, yes. So coming to 1024 zettabyte represents what? 1 yottabyte. Here I given the data storage units up to yottabyte. This is the highest size at present. Observe, 1024 zettabytes represents what? 1 yottabyte. It is very huge volume of data. See, this much of bytes it going to be occupied. This much of megabytes there. This much of value of gigabytes we can store, this much of terabyte value we can store. Okay, this much of petabyte value we can store. Okay, this much of hexabyte value we can store. So this is the large volume of data represented by what? Yottabyte. Okay, so this is about data storage units. Okay, the basically these data storage units are represented in the form of what? Bit, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, hexabyte, zettabyte, and yottabyte. But you need to remember, in programming in C language, this 8 bits represents what? 1 byte of memory. See, in future in C language data type representations, there I can tell all the data representation in the form of what? Bytes. Integral occupies 2 bytes of memory, character occupies 1 byte of memory, float occupies 4 bytes of memory, double occupies 8 bytes of memory. There we are going to be using this word about what? Bytes. Okay, see, at present you should remember about this word about bit and byte, most about this byte. Okay, in C language, through program we are instructing and storing the data in the form of what? Bytes. Okay, yes, that is what I want to convey to all the students. Fine. I hope you clear all about these bit representations. Okay, Nibble, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, hexabyte, zettabyte, and yottabyte. Okay, and coming to the next standard code is called ASCII. So many in interviews or everywhere they may ask the question. Okay, in C++ maintains what type of standard code? ASCII standard code. ASCII represents what? American Standard Code for Information Interchange. Okay, what is ASCII stands for? American Standard Code for Information Interchange. For developing C and C++ application, we are going to be using and following this ASCII standards code. Okay, always remember, in C++ we are going to be developing the application based on which standard code? ASCII code. If you go with the high level programming languages like Java, Python, and so on, there we are going to be maintain what? Unicode standards. But coming to C++, here we are going to be maintain what? ASCII standards. Okay, the American Standard Code for Information Interchange, or ASCII code, was created in 1963 by the American Standards Association Committee, or ASA. What we can call ASA is nothing but American Standard Association Committee. The agency changed its name in 1969 by American National Standard Institute, or ANSI, as it is known since. Okay, fine. See, this is additional information, but you need to remember what is ASCII stands for. American Standard Code for Information Interchange. We are writing in C++ based on ASCII standards. Okay, yeah, that is fair enough. Okay, so this is a basic chart about the ASCII standards. Some ASCII control characters are there, printable characters are there, extended ASCII characters are there. Okay, so I told you 8 bits represents what? 256 value, correct? See, that can be categorized here 0 to 255 characters. Okay, see why I explained bits in detail, maybe all the students understood now, because the ASCII is going to be represented what? 0 to 255 characters. Okay, here some signed characters are there, unsigned characters are there. At present you just remember it, 0 to 255 characters represented what? Unsigned characters. Okay, 0 to 255 characters represent what? Unsigned characters. Okay, see, also suppose some signed characters that represented by what? Minus 128 to 127 characters. Okay, 127 characters. See, in the ASCII table it is available. Observe, the 0 is nothing but null character, 127 what? Delete. Okay, up to the 255 NBSP, number space. Okay, suppose you may give more than 255 numbers, what will happen? We'll discuss in detail in the ASCII video. Okay, there I try to prepare one ASCII explanation video. There you can get much information regarding this complete ASCII standards. But at present, this is enough for here understanding. Using C++, we are going to be developing what kind of standards? ASCII standard code, that is represented by what? 0 to 255. How it come? Because based on 8-bit representations I explained. But you can also observe here, the number 65 decimal value represents what? Capital A. Internally, the 65 value represents what? A character, capital A character. Capital B represents what? 66. Capital C represents what? 67. Like capital D 68, capital E 69, capital F 70, capital G 71, so on up to capital Z what? 90. Just you need to remember this point. In ASCII chart, capital A represents value is 65 up to Z 90. Coming to the small a, okay, try to look out small a, 97. What is the value? ASCII value is what? 97. A represents what? 97. B represents what? Small a represents 97. Small b represents 98. So on. Small z represents what? 122. This is the ASCII value for small z is what? 122. Here these 2 points at present, try to remember it. Remaining things I try to discuss in detail in the next coming sessions. Okay, I hope all understood about the today's session regarding what is data storage units, the data measurement charts like bit, nibble, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, hexabyte, zettabyte, yottabyte, their sizes, representations, okay, shorthand representations, okay, very important, small b, capital B. Small b represents bit representation, capital B represents what? Byte representations, okay. And what is ASCII? ASCII stands for American Standard Code for Information Interchange. And how to represent and ASCII chart. In the ASCII chart, how it going to be represents what? 0 to 255 characters, okay, 0 to 255 characters. We discussed there, capital A represents 65, okay, small a represents 97 to 122, capital A 65 to 90, okay. See, this is about the today's session, okay, regarding data measurements and ASCII code. If you really like this, make it like and subscribe my videos. You may get more updated videos regarding this programming in C language. Thank you all.